Hello, hello, my people. How's everyone doing? Today, we're getting ready for the second first flight of Code Hawk's very exciting moment. And this time we have a puppy raffle. Who doesn't love puppies? And so, Patrick, take us away. Let's kick things off. For those of you who don't know us, my name is Juliette. I'm leading developer relations at Cypher. We have Patrick Collins in the house, CEO of Cypher. Say hey.
Hello, hello. What's going on, everybody? Hope you're ready to find some delicious, scrumptious bugs because we put a lot in here.
Love it. Nice. So, Patrick, first of all, let's kick things off. Take us through it. What are first flights and why do they matter?
Yeah, absolutely. So first flights are a way to bridge the terrifying gap between a new security researcher or a new Web3 auditor and a professional or intermediate one, right? So competitive audits are what we found and what we've seen from community members and other security researchers in the space is competitive audits are probably one of the fastest ways to learn, get feedback, grow as a security researcher, right? Because you get to see the security reports from other people. You understand the code base really well because you did the review yourself, and they are a phenomenal way to learn and grow. However, they can be very challenging and very difficult. And maybe a code base takes you a whole week to go through, right? They can be very time intensive. They can be very daunting. You can feel that imposter syndrome. And a lot of people have felt that first time they do a security review, they do an audit, they go, I'm never going to find anything. This code base is so hard, blah, blah, blah. The thing is, as you get better at security, you can pretty much come up to any code base. And this is literally what we do at Cypher. And when a protocol comes with us with a code base, we don't go, oh, if we find some bugs, here's what we do. We look them dead in the eye and we say, we are going to find bugs. And doing these first flights, that's the level of confidence we want to distill in you that, yes, you are going to find bugs in these contracts. You are going to help make these protocols more secure. So these first flights are these much easier, much smaller code bases. These aren't real protocols. These are protocols that I've coded up or somebody has coded up, specifically with some bugs in them to teach you and get you that confidence as to what these security reviews feel like and should feel like, especially as you get better, right? So in the beginning, maybe you only find bugs in first flights, but it's that exact same process that's going to get you to find bugs in real competitive audits. So that's what first flights are. That is the goal behind them, to scale you up, make you better, and have fun doing them as well. Does that answer your question?
Nice. Yes, sir. Now, today we were speaking about a puppy raffle.
Yes.
What is the contract meant to do? Give us a bit of an overview of what we're expecting.
Absolutely. So today's challenge, or this week's challenge, I should say, this week's first flight for you auditors looking to pick up on some bugs is a puppy raffle. Now, if you've done some of our security curriculum, our Web3 curriculum in the past, if you've done the Foundry course, if you've done the Brownie course, if you've done the Hard Hat course, all of these courses have had some type of raffle in them. So I will say, though, if you don't know anything about Solidity or anything about smart contracts, I would highly recommend you watch the Foundry Flow course. We released it on my YouTube back in June. We are releasing it on a new platform very soon. Stay tuned for that. I highly recommend you watch that because that's going to give you all the prerequisites to be absolutely stellar at these first flights, at these competitive audits. So in all of our curriculum, we've done some type of raffle. They are very minimalistic code bases that work great in Web3 and solve a real problem. In Web2, having corrupt raffles, having corrupt lotteries is not uncommon, right? There is the McMillions scandal where those fun little Monopoly tokens were actually a big scam, and around $13 to $24 million was stolen because people had access to who picks the winners, and sure enough, they picked themselves, right? And Web3 actually fixes this problem. Web3 allows us to have provably fair raffles, provably fair lotteries. So that's exactly what this code base is going to do. Let me just do a quick share my screen here. So make this a little bit bigger. Like this. Okay, there we go. So I have the code. Let me zoom in a little bit too. I have the code already cloned to my VS Code here. If I do git remote -v, I'm going to grab this and I'll post this in the chat here. So if you want to, I'll never trust Ronald McDonald again. So if you git clone this link, it's in the chat here. This is the code base that we're going to be working with. This is the code base for the competition. If we go into the README, readme.md, we can actually see this adorable, cute logo. Thank you, designers, for making this so adorable. We can see the contest details. We'll go over that in a second. But let's just talk about what this actually does. This project is to enter a raffle to win a cute dog NFT. The protocol should do the following. There's an enter raffle function with the following parameters. You can pass an address array of participants. So if you and your friends want to enter the raffle in one function call to save some gas, you can actually add a list of participants. And this enters you into the raffle. Duplicate addresses, however, are not allowed. So you can't enter your own address multiple times. If before the raffle has completed, you want to refund, you actually don't want to be part of the raffle anymore, you can actually refund your ticket and you can get the value back if you call this refund function before it has been drawn. Every X seconds, so there's a certain parameter that picks, the raffle will be able to draw a new winner and minted a random puppy. So there's a select winner function where it'll pick a winner from the entered participants. And whoever deployed this protocol, the owner of the protocol has an address. Oh, I should have updated this. That will take a cut of the value, right? So they get a fee for deploying this contract. I think it's around 20%. We'll actually see in the code base when we look into it. So that's what this is supposed to do. And if you go into the code base here, just really quickly, we can scroll down and we can actually see some of these puppies and what they look like. They're very cute. Let me share a different screen and we'll see this, what this looks like on IPFS. So here's what these puppies look like on IPFS. This is obviously an IPFS hash. This is the image of the puppy. One is a Saint Bernard, one is a pug, and one is a Shiba Inu. So these are the adorable puppies that you can win. They also have different rarities, which is very fun. And let me show my other screen. I believe it's this one. Yep. Okay, cool. They have different rarities. You can see there's a common rarity, there's a rare rarity, and a legendary rarity, where you have a 70% chance of getting common, 25% chance of getting rare, and a 5% chance of getting the legendary. And here's the code base. You'll see it when you clone it. You'll see all the functions, and
Nice.
that's what it does.
Thank you so much for that, Patrick. I think what's amazing about this is that, and especially going back to our call last week, you're doing exactly the first step that we should always be doing when auditing a code base. You're giving us some context, taking us through the README. Something that you mentioned that was super critical to me was really grasping that often bugs are coming from like understanding the business logic, even beyond just trying to do some funky cryptographic EVM play underneath. So thank you for taking us through that. That's super important. Now, the next step usually in this roadmap would be to go through that README, run all those methods, and try to clone the repo locally. I think that's super important for anyone who's going to get into this contest. They're going to want to make sure that they're able to do so. Could you take us through running that repository locally for everyone who's watching?
Yes, absolutely. So let me reshare this. So I already have it cloned here. But what you'd want to do is you'd want to run git clone and then paste the link to the repository, and that'll set up your repo as such. If you're unfamiliar with Git, if you're unfamiliar with cloning, we go through this in our curriculum. So definitely be sure to watch that Foundry full course or prepare for the upcoming curriculum course, which is going to come out hopefully very soon. But then once you do that, you'll get this in here. Now, this is the folder for the 2023 10 puppy raffle here. Now, if we go to the README should have all the docs to actually set this up. So if we scroll down, we have getting started. You need Git and Foundry. Yes, I have Foundry because I can run forge -- help. Great. And that actually returns something. We have Git, obviously. And what we can just do is we do git clone, cd to the repo, and run make. So you will need make as well. We have a make file. If you don't have make, what you can do is you can just run the remove command, which is here, the install command, which is here, and the build command. So that is how we build this. So we just run make, and this is actually going to run those 3 things for us. So it's going to run remove, which removes a whole bunch of Git modules stuff. It basically cleans out your repo just in case you added some weird stuff. It installs dependencies. So we do use some Open Zeppelin contracts. We do use this very specific base 64 Git repo as well. And then we actually run the build command, which compiles all the contracts. So if you've done that successfully, this is what it will look like. There's some warnings in here about unused variables. We are going to ignore them, or maybe we shouldn't ignore them. I don't know. That's on you to decide. So once we have that built, you can actually go back to the code base. There's some optional Git pod stuff. The Git pod stuff actually doesn't work because it is for some other stuff, but we can run forge test. So we can run all the tests, and we can see there's 18 tests here. Oh, wow, look at that test coverage, huh? And we run forge coverage. You can actually see what the exact code coverage of this test suite is. And it is around 82 or around 82% for Puppy Raffle and 67% of branches. And it looks like it's green. So sorry, since it's green, that means it has really good test coverage. Sorry, you're not going to find any bugs. Competition over. Just kidding. We put bugs in here. So if you want to try some proof of codes, that test suite is really where you're going to want to do that. So in the Puppy Raffle test.sol, if you think you found a bug, this is where you can stick your own test suite. Go to the bottom. Maybe you can do function test my bug like this. Do like a public. Maybe we'll just do a console.log. Hi. I think we have console imported. We sure do have console imported. And then if you want to run just your test for your proof of code, what you can do is forge test --mt, paste the name of the test that you want to run, and it actually worked, but we didn't see a console.log because we need to add the verbosity. So forge test --mt test my bug -vvv. 2 or 3 V's is usually fine, and we see logs are high. So that's how you run your own test for a proof of code here. And that is how you set this up, Juliet. Thank you for asking.
Sick. Thanks, Patrick. I'll add a little bit of a hint. Just because there's 80% coverage doesn't mean that the tests are right. Probably you always want to assume that whoever wrote them missed something. So keep that in mind. It's always good to know the coverage, but it's not necessarily always foul-proof. And then something else I'd like to add is, this code base, how many lines of code do we have here, Patrick?
Great question. So it says in the contest details here, we have an NSLOC, which stands for number source lines of code, 141, and a complexity score of 111. And this is actually great for you competitive auditors to keep this in mind as you're doing this, because what's going to happen is you're going to get a better sense of how long it takes you to do a security review on a certain size code base. And this is actually how most independent auditors price, or independent security researchers price their services. Hey, this is 150 lines of code. Boom, I've done a ton of audits of that size. I know exactly how long it's going to take me to make sure it's secure. And these are the stats here. There are 2 tools, for those of you who are unfamiliar, there are 2 tools you can use to actually get these numbers. One is this tool called CLOC, or Count Lines of Code. I have it installed. You can just look up Count Lines of Code. There's a GitHub repo with like 17,000 stars or something with this. And what you can do is you can do CLOC in the directory. You want to count lines of code, and it'll count all the lines of code in that file or in that directory, right? So there's only one file in this directory, so it's only counting, the one text file. And we can see, we do indeed see the 143 lines of code. We've also got 43 comments, 30 blank lines, and these are obviously skipped. Now, the more advanced tool that we most of the time use in the Solidity smart contract security world is this extension called Solidity Metrics. And that's here. If you're using VS Code, you can use this. If you're not using VS Code, too bad, I guess. But so this is for a VS Code extension. And what you can do is you can right click or command click. If you wanted to get these number of lines of code, you can command click or control click. Since the scope of this audit is just SRC, we'll right click, hit Solidity Metrics. And what this will do is it'll create this report here from the consensus diligence team. And if we scroll down, it actually gives us a ton of goodies about the code base, including source units and scope. And we have this complexity score, and we have the number of source lines of code, exactly the same as what CLOC gave us. One other thing that this gives us that's really nice, if we scroll all the way down to the bottom, and this is something that a lot of security researchers will do themselves, is they'll draw these things called inheritance graphs. So the puppy raffle contract is in ERC 721 and is an NFT, and it's ownable. And you can see the dependencies between contracts, and this is how most attackers think. Attackers think in these graphs, and this can give you a good idea of, hey, where does what work with? That was too complex, but it's really helpful. Then we also have this call graph where we look at different functions and what do they call and where do they call it from and how do they call it. And so we can see this little call graph, and maybe this will spark some ideas of, oh, look, refund, or oh, look, token URI calls this base URI function. So that means if there's an issue with base URI, there's probably an issue with token URI. Select winner calls total supply. So if there's an issue with total supply, there's probably also an issue with select winner. So these graphs can give you a good idea of where to think about attacks. And then we have some contract summary stuff here as well. This is actually a place that I've gone many times when I'm doing a security review. When I'm looking to attack a contract, I say, okay, internal functions I don't care about because they're internal. Public and external functions, though, those are the ones that I can call. Those are the ones that I'm going to call when I want to break a contract. So it gives a lot of really helpful information. We also have this mutability thing where if it can modify state or not, the ones that can't modify state, maybe those are the ones that are harder to attack, but the ones that can modify state, maybe you attack those. So I kind of went a little bit deeper than you asked for here, but that is how we got those stats.
Beautiful. Love that, Patrick. It's nice because it also takes us a bit through the scope of understanding scope, the dependencies, and that part, which is super critical to making sure that we're finding bugs within this defined scope. So thank you so much for that. Now we have some questions coming up from the chat. We have a question from Cadena, and they're saying, is it necessary to submit a report fast? I mean, if many auditors found the same bug, does the submission timing make a difference?
Great question. So the answer for competitive audits is no. If you submit it in the first second of an audit opening or the last second, it doesn't matter. Now, there are certain competitive audit platforms that have something called like bot races, where if you submit in the initial first hour, they go to this bot race. CodeHawks, we don't do that. So no, it does not matter when you do your submissions. If you're doing, I will put a note here for bug bounties. If you're ever going to compete in a bug bounty, it does matter. In bug bounties, it is first come, first serve, but CodeHawks and first flights, it doesn't matter. And this is very great for you auditors. That way you don't have to rush yourself. As long as you get your findings in by the deadline, we will give you feedback on your findings. So great question.
Nice. Up next, we have Epios, who says, do you have any advice for someone struggling with writing proof of code section specifically?
Yes, I need to release a video called How to Best Do a Write-Up, which would answer this question. In the meantime, I can answer this at kind of a high level. The burden of proof is on you to prove without a reasonable doubt that your bug is indeed a bug. That was almost like lawyer speak there, Juliet. Beyond a reasonable doubt. You need to prove that your bug is a bug. So for the proof, so there's a section in the write-up called proof of concept. Sometimes people also call it proof of code. And this is where oftentimes people will write a test suite to say, this is exactly why this bug exists. This is exactly how this bug exists. What a lot of people do these days, actually, let me reshare my screen here, is let's say, create a new file. Let's say this is my write-up and I'm at the, let's do, say I'm at this write-up and I'm at the POC section, proof of code. Maybe what I'll do And here's what I love to see for a phenomenal write-up. This is a little bit more advanced. Is I'll add like a little details tab, a little details HTML, little summary thing. It says code. And when we preview this in the Markdown, it creates this little drop down. And what I can do in here now is I can add some code formatted with Markdown. By the way, if you're like, what the heck is he doing? ChatGPT can help you out with some of this Markdown formatting. This is where I'll add my test in here. So let me copy this, paste it in here. Let's say this was my test to prove my bug exists, right? So if we look at this now it's kind of hidden inside of here. That way it's not kind of clogging up the write-up, but this is where you'd write the test. And what I'll normally do is I'll say something like copy, paste the following function into the copy Raffle test.t.sol. What a lot of other people, this is one option that you can do. What a lot of other people will do is they'll actually create a, I think it's a git changes file, where you can just run something like, it's either like git apply, I'm forgetting the exact syntax here. It's like git apply or something, and you can just automatically change the repo with whatever git changes that you have, and they'll put that down, same thing in this little drop down, right? The other thing that you can, and this is if you have a test suite to prove your test case, right? So this can be, now it can be very difficult to write a test case for everything. So sometimes people will do a write-up of just like steps, like step 1, fund the protocol with 7 ETH. Step 2, call steal money function, fund the protocol with 7 ETH. Note the balance of 7 ETH, call steal money function. Now the protocol has no money. It's supposed to have money. Boom. And this is kind of a more written, verbose proof of concept or proof of concept or proof of code to do this. So either one works. But again, the burden of proof is on you. So if you do a write-up and a judge goes, I don't believe you, this is where this is going to save you. Having this is the thing that says, this is the proof. Having a test suite, having a code base that actually says, here's exactly what was not expected that is happening. That is the proof. And oftentimes the proof of code, having a test suite, is the difference between a selected report and just a decent report. Because again, this is the proof that your bug is a bug. So hopefully that advice helps. Yes, I will come out with a video to give you more tips on doing a phenomenal write-up. Great question.
Right. We'll keep you accountable, Patrick. Thank you. That was a great rundown. We have a few more questions before we wrap up. Shikar here says, what are those compiler warnings? I think he's referring to the ones that you were showing earlier.
Yes. So I guess without giving too many hints here, pull this up now. So if we do forge build again, whoops, let me clear the cache. Delete. Let me also clear the output. Delete. Clear the cache. We run that again. We're going to recompile all of our contracts. First off, we see the Solidity version is version 0.7.6. So this is an older version of Solidity. Maybe that's a hint in itself. And older versions of Solidity looked a little bit different. And if we go to, we take this line, it says visibility for constructor is ignored. If you want the constructor to be non-deployable, marking it abstract is efficient. So we have this constructor internal. If we do a search on our code base, this is actually coming from our dependencies. So this is ownable.sol. This is in the Open Zeppelin contract. So this is a warning coming from here. And the reason for this is because this is an older version of Solidity. I guess this is a hint. You can actually ignore those warnings. They're not a bug. In Solidity, you can just have it without this internal keyword. But in older versions of Solidity, a lot of them had like an internal or like a public or like, oh, maybe you can't have public. They had some type of visibility for constructors. You don't need them anymore because they don't do anything. So the Open Zeppelin contract libraries of this specific version actually did use this internal keyword. So if we look at this, that's what these all are. Hey, constructor internal, constructor internal. Visibility for constructor is ignored. I guess there's this unused local variable, which is in the deploy puppy raffle, but this also doesn't really matter because this is in the deploy script, which is out of scope. And then finally, test my bug, which I just created. So you're not going to have that. So great question.
Yeah, thank you for that rundown, Patrick. I think two key lessons that come out of it for me is number one, always checking that Solidity version and what bugs are common within that Solidity version. I think that's a great little tip. And then another one is the dependencies, right? A lot of these code bases are depending upon other projects, and if we don't quite grasp how those contracts are working, then those bugs may come into ours. So that's super useful to know.
Spot on.
Now, oh yeah, sorry.
Oh no, I just said spot on.
Oh, nice.
Agreed.
So we have a few more questions coming up. We have Tino Tenda, which says, I encountered an issue auditing password store. I discovered that one finding may be related to another, and I was unsure whether to submit them separately or combine them into one finding.
Yeah, great question. And so you'll run into this a lot. And in a private audit, this is a lot easier because you can just kind of do whatever you want. You can do both. You can do one. Doesn't really matter. Competitive audits, it's a little different, and it does matter. So for competitive audits, and this is actually in the CodeHawks docs, as of right now, the rules for whether or not to submit one bug, whether or not bugs are going to be combined is what is the root cause? If the root cause of a bug is the same, it is one submission. It is one finding. So for example, let's say a function is missing access controls and it allows someone to steal funds. A function is missing access controls and it allows somebody to change the owner of the contract. Those both steal funds and change the owner of the contract. Those are both as a result of a function missing access controls. So that is one finding. So this is where you separate the root cause and the impact. And that's actually a tip for a phenomenal title to your submission. The title of your submission should be the root cause plus the impact. And if there are multiple impacts, you can add that in the description or the impact of your write-up. But whatever the root cause is counts as one finding. There has been some talk as of recent to implement a new rule where if you get an incorrect impact, you actually will get half credit. So you'll get less credit. So just keep that in mind, because it is really important. Because again, at the end of the day, your job is to help make the protocol safer and prove to them why the bug you found is an issue. So if you do not have a correct impact, if you just go, oh yeah, there might be a reentrancy or something, I don't know, that's not very helpful, right? It doesn't help the protocol be safer. And if anything, it actually could be harmful because the protocol could make a change that they don't need or that makes the protocol worse. So root cause plus impact. But yes, to answer your question directly, if they have the same root cause, it is the same finding. It is the same submission.
Nice. Thank you, Patrick. Another one here is small of insufficient test coverage a valid finding?
So in an audit report, I will mark that as an informational. So for competitive audits, for CodeHawks, we don't do informational findings. Additionally, this would be out of scope for this one. So if a contract says, hey, can you take a look at my test suite as well? This is where competitive audits and private audits are a little bit different. In a private audit, I'm ripping through a protocol's test suite. I'm like, you need to add tests here. You need to do this. We've found a ton of bugs often just by writing better tests, which might help you for competitive audits. Maybe not. I don't know. Might help you on this one. It's definitely helped on certain competitive audits. I know I've found bugs in competitive audits from writing super sick tests. But no, for CodeHawks, it is not a finding. For private audits, most of the time it is an informational finding, but it depends on the rules of the competitive audit platforms. For CodeHawks, they do not count.
Nice. And I guess a similar one is if they need to submit findings related to gas, under which category should they be submitted?
Yeah, I don't think we do gas findings for CodeHawks on the first flights. Yeah, so we don't do gas findings for first flights. There's a lot of rationale for that. One of the biggest ones is that our tooling is getting a lot bigger at doing gas findings, and we we want to focus on security. We want to make sure these code bases are secure. Gas is a little bit less important. Plus, it can get a little bit hairy because technically I could say, oh, just rewrite the whole thing in assembly and you'll save a ton of gas, which is true. But like, so gas for at the time for CodeHawks, gas submissions are not allowed, but maybe in the future, we'll see.
Nice. And is logical findings like checking for duplicates in an array? That's some more gas efficient way of doing things. That's probably not acceptable because it's still a gas finding, right?
How do I answer this without giving away too much alpha? If it's purely a gas issue that results from this, that is not a finding. That is how I will say that. If there is no security issue, other than if there's no security issue, then it is not a finding. That is what I will say.
Love. All right. Well, some good practices for submitting a test and its console outputs as a proof of concept. I think we already went through those.
Yes.
Is there anything you'd like to add on there, Patrick?
Nope. Yeah, I think doing as I kind of just showed right there, that is the way that I love to see it, because it puts you add your test suite, but it also doesn't clutter up kind of the rest of your finding. So that's how I would recommend doing it.
Nice. Now, in terms of the first flight program, how long is it going to run?
Yeah, great question. So because I'm releasing a security course very soon, and some of these are going to be in the security course, we're doing weekly for the next couple of weeks. At some point, we will switch to monthly, though, because I don't have time to write 52 code bases, but I think I have time to write 12. So we'll probably switch. So we'll probably do these weekly ones for the next couple of weeks, and then we'll switch to monthly, probably.
Any limitations in terms of tooling that people can use to catch vulnerabilities?
Yeah, great question. So to answer on a high level first, there's been some studies done. There was one big one in the last 6 months to a year where they found out that actually 80% of all production and competitive audit bugs are machine unauditable, meaning no tool in the industry would have caught them, and only some type of manual review at the moment would have caught them. This includes AI tools. So to answer your question more directly, yes, there are a lot of limitations. Tools are not, at the moment, our tooling isn't good enough in Web3. It needs to be better. This is not like a huzzah, like, yay, tools aren't going to replace us as auditors. This is actually a bad thing. Our tools need to be better and they need to catch more bugs. Right now, they don't. So yes, you should be running tools because they will catch bugs. They will catch 20% of bugs, which is still a lot of bugs, but the vast majority come from some type of manual review. Can bring all my arsenals as long as they get the job done? Yeah, you can bring whatever tools you want. Doesn't matter. Absolutely. Bring that arsenal in. Find those bugs.
Love that. I think this relates to the question that you were saying, the comment that you were saying earlier, Patrick, in terms of a DOS attack through gas.
Well, denial of service attack is a security issue, right? So that would be a security issue.
Nice.
You're giving the other auditors some alpha here, huh?
Oh, love it.
Or not. I don't know. I wrote the code.
Thank you, Shakar. Now, up next, last question of the day. What's the best way to generate a fuzz test?
This is a super loaded question. I have a video on my YouTube channel about fuzz testing. If you want to go to that, we'll explain it there. So Patrick Collins YouTube, we talk about invariant tests. We talk about fuzz tests. Go check that out, and we will show you how to do it in Foundry.
Nice. I'll be sharing the link here so that you guys can have it as well. All right, so that is it for today. Thank you so much for everyone who joined. I'm really excited to kick this off with you. If you're interested in that course that Patrick was speaking about, I shared the link on the comments. Make sure you sign up. We'll be doing some early access launch soon. So really excited to kick this off with you. And of course, if you have any questions, feel free to reach out. We're on Discord, we're on Twitter, we're anywhere you are.
This is probably the best beginner code base for any security researcher. I'm probably going to be pushing this and telling new security researchers to look at this code base because of the types of bugs that are in it, because of the size of the code base. So this is a phenomenal learning opportunity for everybody here. And let's see who can find the most bugs.
Nice. See you in cyberspace. Bye, guys.